Hello again. This is day 1. This is the first day of GDC, the ending of the first day. This is quite an eventful day. I'm going to structure this a little bit because I've taken notes for the talks. So I feel like I have more to speak to, and that's just going to structure things more. So I have my loose structure here, this introduction, the talks, the people stuff in between, which wasn't a lot because it wasn't really meeting people, and in conclusion. For reference, just for some housekeeping and things to keep in mind, the expo floor, where all the booths are, that isn't open until Wednesday. So my plans are networking, or doing any networking, I'm going to save mostly for Wednesday. Not that I didn't do any at all today. I did a little bit, but most of that's going to be Wednesday. Tuesday and today are going to be talks. I woke up this morning, I went over to GDC, I arrived around 8:40. I underestimated how long the line was going to be, vastly, and I arrived in half an hour late, sorry, as a result, because the talk started at 9:30. And so it took a while. I got there by 10. So next time I'm gonna wake up early, because you're given this orange wristband to show proof of vaccination. I don't know if they're gonna do another one or have to do it again, just to keep it consistent. I genuinely don't know, so I might go early just in case, and while I'm there I could get something to eat or something. I don't know. I'll try to go a little early though. Anyway. But the actual talk, I got there halfway through the first one. The first one's about water, it's about real-time water simulation, which is cool. I don't have all the context for it, but I do have an idea based on just the concept of a real-time water simulation. And when they say water simulation, they're only talking about like the actual water fluid physics, like then rendering water, the visual surface of water, and the fluid dynamics of it, which I didn't really get to see. I mostly saw the rendering section. They also have an underwater camera bit, which is, they mentioned offhand. I'll come back to that because it's actually really interesting to me. Basically, what they did is they have a specific algorithm to optimize how triangles are refined. That's where I came in. And basically, I'm oversimplifying a bit, but using some fun shader math, they're able to selectively refine the triangles using the tessellation stage. If you don't know anything about graphics, there's a graphics pipeline, and usually goes, the main ones that people usually encounter are the vertex shader stage, where the vertices are built. Then there's tessellation, which is where the triangles are drawn. Then they're colored. Then they're rasterized at the end. Tessellation doesn't usually come up as much. Usually you're going to be focusing on vertex and frag, again, when you're starting out. I never touched, for example, tessellation before. I never had a reason to, but this is a great example of why you would. And so a lot of the work in optimization is about effectively controlling how much of the mesh is refined. And it's also has all this physics. It can flow like water, it can create rivers, it can create waves. The thing I wanted to mention very quickly was that they actually have a physically based volumetric rendering system for lighting underwater, which they went and did the research, and it uses chlorophyll and yellow matter and all those particles that are used for the lighting of water, which is really interesting to me because I actually have worked on something like that before. So I was intrigued and kind of disappointed that they didn't get to talk about it more. there were some questions. I don't think they're particularly interesting questions, so I'm going to skip that. The next talk, one of the more interesting ones, was Gran Turismo 7's sky rendering. Now, this one was good. I think it's really good at giving you a context and helping you build up a foundation and explaining why they were doing the things they were doing, which is good. This is a problem I have with another talk later on. We'll come back to. Gran Turismo 7 sky system is nuts. Basically, get this. So volumetric rendering, so what they're doing is they calculate all of the bouncing and scattering that happens in the atmosphere analytically, which means they're not trying to make an approximate solution. They're trying to get like as close as they can exact. They're trying to find what's called a volume rendering equation to figure out the actual lighting condition, and they're using a whole bunch of calculus for that, like literal calculus for that, and using a bunch of what are called phase functions, which are approximations of how light scatters when it hits certain particles. So the main things you should know about light, and they explain this, is light can either be transmitted, and this is just good to know in general for graphics programming. Light can be either transmitted, scattered, or attenuated. Attenuated means it's absorbed, scattered means it's going away or towards the camera. So they create a system for scattering. Where is the light going to go? Is it going to go away or towards the viewer? How much of it is just going to go through unchanged, and how much of it is going to be absorbed? And this affects a lot of things, because how it's absorbed isn't clean. The absorption's dependent on the wavelength, and they actually calculate it by wavelength, turn it into a chroma space of XYZ, and convert it to RGB from there. In the process, I am not sure how they did. I've struggled to figure out how we're supposed to do that. But they managed to do it, which is pretty impressive. Their rendering system is 20K lines. So it's a lot. Also, the main things you need to think about is that turns out atmospheres have aerosols, so a bunch of things besides air, like water vapor, and that makes everything so much more complicated, and that's going to be a recurring theme, especially with terms of scattering, because there's a bunch of different ways you can do scattering, different equations. One's called Rayleigh, which is like good for air, really good for air, and Mie scattering, which turns out to be not the best, but but it gets pretty close in certain particular cases, and they use that one a lot. The thing that they end up having to do, essentially, is they calculate everything using these phase functions and using the whole continuous spectrum, and it's extremely expensive. So expensive, in fact, you could never have used it in a game on its own because it wouldn't work in real time. So they do the clever thing of just computing it and then saving it to a 3D texture, and then they use it as a lookup table. And this is going to be a recurring thing because they basically have 10 lookup tables, one for different times of, one is for a clear sky to night, one is from cloudy sky to fully cloudy night. This is important for weather lighting. And they basically interpolate between these textures. And this 3D slice is a 3D texture because they want the slices to be based on time of day, or based on time. Yeah, Yeah, they have the based on time, and then based on a time of day, they interpolate between those lookup tables. And it's not just those either. They actually have more lookup tables than that. Basically, oh yeah, so they have the weather lookup 3D lookup texture, then they have the time lookup texture, the clear sky, so that's 2 3D lookup textures. Then they have, they use the angle for scattering to help create the sky, and they have some stuff to try to optimize it, involving like controlling how much detail is around the sun. The weather lookup texture itself actually is broken down into 2 bits. So it's actually 3, now we have 3 lookup textures so far, not just. And then, and look at this, and even for fog, which like local fog for example, on the ground, they have even more lookup textures. They have 2, one for scattering of the light and one for the attenuation of the light. So they actually have even, right now that's 4 lookup textures. I believe. And then they ray trace, and then they use a 2D texture for determining cloud density and a 3D texture, so that's another 5 lookup textures for ray marching, so that's how you generate clouds. You're basically sampling a volume to determine how much cloud is going to be. That's like the basic broad strokes. I won't get into it. That's like the broad strokes you need to understand. They store more stuff about the light in a buffer, so that other steps in the process can access it. What actually is even more interesting. Basically, in order to get it really fast, they have it so that their light results are actually spread out across multiple frames. So every frame doesn't actually have the most recent calculation. It really has the frame before its most recent calculation. So they have one buffer handle the calculation, is calculating it, and the other buffer is actually presenting it to the screen. So that makes it even faster. Yeah, you can tell, this is fucking dense. This is a lot going on, like a lot going on at once. And then all that, then they store they store some light transmitted that's transmitted through clouds in the 3D texture. That's, I think, 6 or 7 lookup textures now. They love lookup textures. Turns out very useful, very, very useful. So this is to make shadows for the clouds. That's why they're doing this. They're calculating it so they can figure out where the shadows are going to be cast on other clouds and other surfaces. And the result is their skies look really good, like really good. I mean, if you had an image of the 2, like real life and the thing side by side, then you would start to see differences, but like you probably wouldn't be able to tell that much unless you were really paying attention and you really knew. It's really good looking. It's very pretty, and it's quite impressive. It's just, you can tell so much work went into it from various different disciplines too, because like, I wish you could see the presentation, because there's all these diagrams and papers that they went through to figure out how all this worked, and a lot of R&D, and it's just like you can tell just the sheer power, the manpower that went behind it. A similar thing, this is going to be a reoccurring thing, because the next talk is God of War 2 Ragnarok, specifically the snow. Yeah, you didn't think about the snow, did you? Underappreciated thing, because the snow system is actually pretty clever. Basically, They open with by saying that they want to give people a lot of control, the artists a lot of control over their work and being able to make something very pretty. And they had snow implemented in God of War 1. But the problem with it was that it's really hard to work with. It requires too much fine-tuning and a lot of trial and error, and it's just super restrictive. And it's just unpleasant to make an entire game around, or an entire game with that system being everywhere, because you're going to have snow everywhere. It's a very snowy game. So I won't go too much into details about like, why because I don't think that's the most interesting part to me. They use some of the technology because apparently they made their own parallax system called SS Parallax their own screen space parallax system. Which apparently someone in their studio invented, which sounds cool. But besides that, I'm not gonna get too deep in the weeds on that. One of the takeaways they mentioned though in this section is they lay out the requirements. It needs to be an arbitrary sized mesh. They need to have variable memory. It needs to have good optimization. It needs to run well on average, not just in the average case needs to be pretty good. Not just the best case or the worst case. The average case needs to be very good. It needs to have a minimal setup. They did the math. They basically designed it at first, did the math by hand, just to plan it out. This is a good example why math is useful, because it helps you predict and plan, and this is what they recommend. They recommend you plan. You ensure your design is good, essentially. You do the napkin math. You plan it out and prepare what this thing is going to need, what are your contingencies, starting from scratch. They did a little bit of R&D on it, and then they decided to do a system of indirect triangle draws. Basically, it's tessellation again. What they're going to be doing is they're going to be trying to find ways to combine height maps to displace triangles, and then ways to add triangles to help with the displacement, to have things adapt to context and detail. And they have it improved in stages, so it's written in this way where it's in passes. They have a very modular approach. This is one of the takeaways, and you're going to see it show up in the passes. For example, the first pass, they took a mesh from Maya, that an artist made from Maya, and automated the height and tessellation, so you can make a really ugly height system to see if it works. And if you like brush it, and then it will go down and sink into the ground like you would with snow. They basically have a carving texture. That's what they do. That's how they carve it in the first place. And then they have there's a carving shapes, and then there's automation of the height map. So the height map and a carving system, they combine to the same render target. So same, I guess, a texture or something. That's not quite right, but that's the best way I can describe it. They put it in the same place. They then blend it with the tessellation system to automate, so they can add more triangles to actually get the displacement to work. They improved it by adding a blending system where it makes it muddy. So if you step in the snow, it gets muddy. Which is a nice detail to have, a pretty good detail actually. It would look weird if you didn't have it. They were worried about like their artists asking for height controls because they were worried that it was just going to recreate the same problem. But their philosophy is like, well, being able to control it is fine if that's not the only way to make it good. And then it's just like a thing you can do, just like you can do. You don't have to do it, you can do it. It's a sign that this is a much better tool because you're not forced to into certain boxes, so they weren't as hesitant. They stopped being as hesitant. Oh yes, this is what. Okay, my handwriting's a bit needs work, but I was trying to write as quickly as possible. So they then made a normal map to apply as well to add more detail to the snow. And this was making it very expensive, so they basically optimized it by creating a advanced, essentially a culling system to simplify the mesh when it's far away, and to get rid of, and to simplify the detail when it's outside of the camera's, if it's outside a certain box, and if it's outside the field of the camera's vision. If it's outside the box, it will just simplify the detail and a bit of things a little bit. It won't quite simplify it entirely. So it's based on like the frustum. And they have this whole system where basically the meshes are subdivided and given IDs based on their offsets. So it's all in one chain of memory. So it's actually really, really condensed and optimal. And they have this whole ID system so they can figure out which ones are, which triangles are in which meshes, and which triangles actually are generated or were there originally, which allows them to simplify things. It's a very clever system. It's a very clever system, and it worked so well, and it was so like the design was so good that they basically finished. They got more time due to circumstance, and they were able to add even more detail, like simulating snow, like actual falling snow, and having like a physics system for the snow, which is also pretty cool. And something that's actually important to say, I think is quite interesting, is that the snow is even more detailed on the PS5, and like dramatically so. Like the PS5, once you start hearing people talk about it, just gives graphics programmers just so much more control and power than they would normally. This is going to show up in the Spider-Man port, because they have to deal with that, the problem of not having the tools that they might have on the PS5. There's an AMD talk. This one I don't quite understand that well yet. The gist, I'll make it quick. The gist of it is so they're trying to make lighting better, like a cheaper ray tracing system to make lighting both cheaper but still look very good. And so they basically store a bunch of information, and then they store a bunch of information, and they don't sample as much, so they have a bunch of holes, and so most of their process is about filling in the holes in clever ways. And there's still some limitations to it, but I might just skip describing this one in more detail, because I don't think I have the best understanding of it to really do it justice. So I'm sorry, AMD. But that's really the gist of what this is about. It looks interesting. Part of it was just, I think it was so technically detailed, but like I feel like it needed to build more of a language. Or I think it's also part of it, I might just not, there's some terms I need to get more familiar with, and concepts I need to get more familiar with. I think it's also like a limitation on my part. I think I'm going to assume that's the main reason, to be honest. I think that would make the most sense, because I'm still new to graphics programming in general. So that makes the most sense to me. Well, I'm still like, early in my career, not completely new, but like I'm earlier on in my career. I want to get to the Marvel Spider-Man talk though, because it's quite interesting. So Nick Software is a company that handles ports, and if you're wondering, why would you need a company to handle ports? The answer is because porting something requires fundamentally redoing out parts of the code, because the code was built on entirely different hardware, and so it works fundamentally differently. And you'll see this happen actually in the port, because the port adds more options for one, because they can, and they kind of have to, as they mentioned, because PC expectations, but also you have to be able to let people adapt on hardware that you're not certain what's the constraints are. So basically, the main things they had to deal with was the fact that PS5 has better debugging, like it gives you better error messages, and it has more memory, and shares memory, is more simpler, has a lot of cool stuff that you don't get to have anymore. Like on computers, your CPU memory and your GPU memory, it's not the same. On the PS5, it's shared, so you have to completely redo how memory works for the Marvel Spider-Man, which is what they do. They basically end up having to create a pipeline between the system memory and the GPU, transfer buffers, and they create a system to keep it manageable, not to break their optimization budget. They create basically a thread to help share resources effectively and to do clean up when necessary, to help speed it up and make it optimal. A lot has been said about ray traced reflection. So basically what they have to do is they have to make their own ray tracing system for the port, and they're using DirectX 13 or D3, D12, which is a low-level API for graphics. Vulkan, for the NGIT people, that's what Vulkan is. Vulkan is one of those. And you can do that in Vulkan, actually. You can create a ray tracing pipeline. I've been trying to do that myself, and it's really slow. And they basically break down the basics of making a ray tracing pipeline, because it's actually not the same as a rasterization pipeline. They're actually quite different. So they explain, basically you need to break things down to acceleration structures, which help with the actual ray tracing, like handling ray tracing detection. So you have your top level structure, which is a scene, basically a scene. Your bottom level structure, which is basically the objects you're trying to hit. You need a ray generation shader, array hit, and array miss shaders. You need to bind the shaders. You need a material shader for objects. You need a lot of shaders. And basically, there's some differences in the memory architecture for how acceleration structures work. So they have to completely change the way they are handled, because everything is now being done at runtime instead of most of it. They had dealt with a whole bunch of performance problems as a result of everything being done at runtime. They basically tried to reduce it with compute shaders and tried to use as much of the existing shader architecture as possible for ray tracing, so they don't create more issues, which worked out well for them. They were able to add a higher res option, which interestingly, because of Ratchet and Clank releasing and Insomniac making tools to increase the resolution, they just were given those, and they got to use some of those tools and integrate them into the game. They had to deal with a lot of issues with GPU crashes and make a whole bunch of really good validation, because you don't have the good debugging tools that PS5 has. You basically have nothing but validation layers, which aren't that reliable all the time because they have quirks to them, which I won't get into. They wrote a lot about having a really well-organized log file, which tells you a lot of detail. They talked about how there's this one bug called device hung, like this one error, which could mean a whole bunch of different things. Like it could be an infinite loop, or you accessed memory that was wrong, or those are two big ones. So which are fundamentally different errors, or you get wrong descriptors, which is, I don't have time to explain that. They also had issues with widescreen support, which there's a bunch of stuff happening on outside the screen that you're not supposed to see, which now you can. So they have to figure out, hey, what are we gonna do with this? And it keeps breaking the UI and stuff, and they keep having to go back and fix it. Like in Unity, I've been there. That's why I keep a very fixed. I don't like adaptive. I keep it locked to a fixed resolution, or not resolution, aspect ratio. But yeah, I thought it made me appreciate porting a lot more. It makes me want to apply to a porting studio and work on that. That sounds interesting. Last talk, and we'll wrap this up. It's a really long video. The Indie Game Summit, which was like a bunch of different people did small little talks about various things in the indie scene. Agrocrab did 2. Both were marketing related. And the summit, both of them, which was done by Nick and Paige, the community manager's Paige. Nick is like the guy who made the company. They did Going Under, and they're working on a new Dark Souls fish game, is how I would describe it. If for those of you who remembered Going Under, which was the game making fun of corporations by having a corporate dungeon crawler. Roguelike dungeon crawler. So their whole point was that, okay, yes, all of us are technically content creators. We cringe at the word. It's really gross. It feels really tacky. But at the end of the day, that's who we are. As gross as it is, and you should embrace the fact that we live in a world that is obsessed with parasocial relationships. You should lean into that. You should have an identity. You should sell yourself. Don't just write like clean, friendly branding. It's lame, it's boring. Be spicy, be interesting. Shit post your way to success, basically. That was like the main argument coming throughout. It could build a sense of authenticity, work off your real feelings, and frame them in tasteful, interesting ways. And they had some tools to explain how you would do that, like assume no one knows who you are, keep it concise, give them enough context to understand who you are, show people what you're doing and what you're working on. Even if you think it's boring, more people will be interested than you think. If it's complicated, this is something that Paige mentioned afterwards when I spoke to her. If something is complicated, you can still use it in a shit post. Even if you can't explain it fully, you can still kind of explain it through a shit post. There are ways you can communicate through marketing that are good, and it helps build expectations. This is because they have a thing about like fandom management, and the lady for that, she mentions the community manager for that. She mentions that you need to be able to manage expectations, and playing off of Paige's stuff. That's a clear, easy way to do that by showing people what you're doing, being transparent about what you're doing, and that helps communicate where you're at. Like state who you are, state where you're at, be more open, because that can actually help manage expectations. And you also need to like correct people when they assume things, because they're going to assume things. The less you give them, the more they're going to assume. Like with Elden Ring, actually, people were assuming wild things, or like wasn't coming out, despite the fact that they just weren't saying anything. And that's, of course, people were just jumping to weird conclusions because they weren't saying anything for years. And make sure you know who you're appealing to. Don't appeal to everybody. You need to control who your fan base is, because if you make it toxic, you're tied to those people, and you're stuck with them. You need to make sure you know who your audience is. Otherwise, it's just going to hurt your games, because people are going to expect something that you're not going to give them. That's a general brand thing in general. You see it a lot with YouTube channels, for example, where like they'll have a viral video that's very different from what they usually make. People come and they sit and they're just like, I'm not in here for this. I'm just going to bounce. One guy did one about, which is more of aesthetic philosophy. It was about authenticity, and the argument that an authentic process or a process that replicates elements of a thing often helps make the thing better. Like if you wanted to make a 80s movie, having it be made on the film instead of recorded digitally makes it feel more authentic, even though it's more expensive. That was really the argument, is that certain kinds of constraints, the constraints of older technology and older processes, force you to get more creative and make more interesting choices. And so he talked about trying to blend modern and old sensibilities. I found it pretty interesting. And then finally, we end with a bunch of stuff talking about casting and voice acting, which basically just, a lot of it ties into this idea of be clear about what your scene is, what the motivations of the characters all are, what their feelings are in the moment. You have to be clear about where the narrative is in the moment, in the present moment, and how everyone might be feeling. You gotta know your characters well and be clear to your actors, but don't tell them what to do, because they're artists and they're going to be making creative choices about their character. They're actors, they know the character. That's the whole point. You hire them to know because they know the character, because they sound correct, because they get it, they're delivering it correctly. So let them do the delivery. You give them the context. You just give them as much of the facts of the case as you can. Be as clear as possible, and do simple things like sound tests if you're recording from home. That's basically the main thing I would summarize both, because they kind of overlap in that regard. Finally, wrapping up. So I mentioned this earlier. I talked to 2 AgroCrab people. I should have talked to more of the people there, but I didn't get to, because I want to go eat. They both have these cute business cards, if you want to see them. So we'll add those to the collection. Oh, cool. Don't really have much to say. It was a short conversation. As for the rest of the day, people-wise, besides the line, I ate lunch. The architecture of San Francisco is pretty cool. I like the campus a lot. I think it's a cool campus. I would walk around between some of the sessions sometimes just to take in space. Overall, I think this was a good day. I learned a lot. There's a lot about programming and graphics programming and how clearly how much work goes, not just the work, but like, I think what was motivating for me is I understood more than I would expect. Some of it because I literally have done some of this research before, like the cloud stuff. I have actually done a little bit of the research into some of the tech involved. So I'm actually quite aware of these kinds of questions, because they show up in volumetric lighting and rendering, like phase functions. That's really common. And something I think it teaches you and it makes it clear is that being able to, like, the complicated math is great for helping you understand theory, helping you understand how to read theory, and helping you understand how to translate it into a computer context. That's why doing the math or being able to do it can be quite helpful, because it allows you to build and plan things like this and think about it and construct it, and have tools to handle these things. Frankly, it's quite inspiring. The Gran Turismo one especially makes me want to go back and improve my code. Makes me tempted to do that. Tomorrow is going to be more hardcore math related, because that's what all the talks are. So I'm curious, for me at least, the talks I'm going to. So I'm curious how that's going to go. I meant to talk to a friend of mine. We didn't quite catch each other today. Playing. I hope I can see him tomorrow. Overall, I hope I can get his stuff as interesting as I learned today. Because, oh man, this is some interesting stuff. This is some crazy stuff. Yeah, tomorrow, get up early, go to the math talks, see my friend. Maybe meet more people. I did see Mark Brown. One last thing, I did see Mark Brown. I didn't approach him because I wasn't sure because he was walking somewhere. I didn't want to interrupt that. But then I looked on Twitter because I was curious, and he mentioned like, oh, if you see me, say hi, and I'm like, oh, shit. So if I see him again, if lightning somehow strikes a third time, and I see him again, I'll say hi. That was a cool moment. But besides that, yeah, that's about everything. So yeah, thank you for watching, and I will see everyone tomorrow.